Okay, let us see this question. It says a particle of mass 4 kilograms is attached to a light inextensible string of length 100 meters fixed at A. The particle is rotating in a circular path horizontally with its center 80 meters vertically below A. Find the angle the string makes with the vertical and horizontal, then P. Tension in the string, linear speed of the particle, and then the angular speed of the particle. So start by sketching. So the case is, again, they are having a particle fixed at A, having a particle of mass 4 kilograms, and then this particle is rotating in a circular path. And of course, it's going to be rotating in this order. So see that the string, after rotating, before it rotates, this is what we have. But when it's rotating, it means it's not going to be vertically. It's going to be at an angle to the vertical and also at an angle to the horizontal. So that's what we are going to start with. But they are giving us the length of the string and the weight of and the mass of that particle. So in our solution, we are going to fix it at a point A. Telling us this is fixed at point A. Okay, so after fixing it, now this is going to be the vertical. This is going to be our vertical. Of course, it's swinging, so meaning it's going to swing when it's at an angle. It's going to be at an angle like that. So if it makes an angle, then it's going to be having a distance from this vertical, which we shall be calling the radius. Then here is where we have our particle of mass 4 kilograms. Of course, it's going to be adding a weight down, which is going to be, we get the mass times the gravity. Now, this string is going to be having tension in it that is going to be pulling the particle towards this. So this is going to be our tension in the string T. Now, they're telling us that this one is of length 100 meters. From there up here we have 100 meters. So this is our center. Let me call it C. Okay, we are simply now we are going to see that this one is rotating after. Okay. Then if this is our particle, remember it's rotating, so it's going to describe a certain circle in this order. So it's describing a circle which I can ably show in that order. When I'm rotating it, remember, rotating it. I think we can see. So down here, when it's rotating, it's describing the circle. So I'm trying to put the diagram of that circle. So this is the case we are having as it's moving. It's describing that circle as you can see there. So they are telling us that now the particle is rotating in a circular path. That is, as you see, with its center 80 meters vertically below A. So from here, they're telling us that vertically below A, the center is 80 meters vertically below A. So that's where our center is going to be, vertically below A. So that is where our center is going to be, as you see. Okay, find the angle the string makes with the horizontal and the vertical. So if I call this angle theta, then I can call this one alpha. Let me call this one alpha. So let me call this one theta, and let me call that angle alpha like that. First of all, we need to determine this radius. Now, of course, we know that there is a force that is going to be pulling this one towards the center, and that force is always what we call the centripetal force. So, based on this, all that, we can now resolve that tension in the string. So, but first of all, we need this radius. But now, let us base on theta so that we can, on alpha, so that we can resolve this. This one is going to be, because this is adjacent, it's going to be T. Now, adjacent goes with the cos alpha. Then this one is opposite. From Sokato, opposite goes with sine. So, meaning, this side we are going to be having this as T sine alpha. I'm basing on this angle of alpha. You can also base on theta. It's up to you. Everything is going to give you the same answer. Anyway, so now from there, we can able start by getting this radius here. If I have this radius, oh, okay. I want to get the angle, but then start by getting this radius r, because I don't have r. So let me call that r. So if I pull out that, I think you can see the radius and there. So this one is 100 meters, this is 80 meters, and this is my r. So using Pythagoras, my r squared plus 80 squared is going to give me 100 squared. So from there you can see my radius is going to be 60 meters with ease. Okay, so get your mark for that radius. Then part A, they want me to get the angle. So my part A, the angle meets with the horizontal. Remember, this one here is our theta, this one here is our alpha. So anyway, you so they want to start with vertical. So you see vertical, I have the opposite. Now this one is going to be 60 meters, and I have the adjacent. So from there, I can see now my sine theta is going to be equal to the opposite over the hypotenuse. And so from here, my theta is going to be getting 36.87 degrees. Then when I come, this one is the vertical. The angle with the vertical, then let me get the angle with horizontal. Horizontal. That angle is alpha. Or you can get this plus this equal to 8. I mean equal to 180. But you can simply get it from here. You can start, I have cos, you can use cos alpha is equal to, we have now the adjacent over the hypotenuse. Anything is going to be the same. So adjacent over the hypotenuse. So our alpha here is going to be 53.13 degrees. Or you can use still sine, this will be the opposite. It's up to you. So you have the angle in the bottom, we have the angle with the horizontal. Then you come, they want us to get now the tension in a string. So the tension in a string, how are you going to use that tension in a string? Tension in a string now that calls for resolving. So if you resolve now vertically, you see vertically we have t sine alpha is going to be equal to the downward force, which is for g. So now 90 from here is going to be 4 times 9.8 now over sine, but my alpha is 53.13. Then I come and I get my tension as so I'm getting 49 newtons. So that's my tension in the string. So basically, then find the tension in the string. Then they want me to get the linear speed of the particle. So the linear velocity, we need the, remember to get the linear speed, it means we need to get the angular velocity times r, but they don't have the angular velocity. So that means that if I solve horizontally in this order, it means that always my t cos alpha is going to be equal to the first f. This force is the force that is keeping it in a circular motion. That force is the centripetal force. So from here, which is equal to now m v squared the whole over r. So I have this. So meaning now my t is going to be 49, then cos alpha, our cos alpha, which is 53.0, we can just put them here because we can get cos alpha. You see, our cos alpha is opposite over adjacent. if you don't want to, if you want the more accurate answer. You can see now cos alpha from there times 60 over 100, that's our cos alpha, is equal to our mass, which is 4, the v we want, over our radius. Our radius is 60. So if you cross multiply, you can see, this is parts by the way. And see if I cross multiply, I'll be having 9 times 60 times 60, the whole over 100 times 4 will be equal to v squared. V squared. So our v there is going to be, you can every put it there. So we have times squared divided by 400. Root answer. So I'm getting 21 meters per second. This is now my linear velocity. Then part B, you want me to get the angular velocity. All I know is the angular velocity is equal to the linear velocity in that form. So this one is 21. It's equal in the radius. Our radius is 60. Now omega. So this one is going to be equal to 21 over 60. This one is measured in rad per second. So, which you can give 2 by 37 by 3, 2, which you can say can give to 0.35 rad per second. And that's going to be our angular velocity or angular speed with ease. So that's how we handle that big number. I think you see everything in circular motion. When you know, the only thing you need to know, always when you resolve horizontally, any force you get should be equal to the centripetal force. Whether you have tension, whether you have friction, it should be equal to centripetal force, the force that is keeping that body in circular motion. Any horizontal resolving you have, it should be equal to that force. That's it, members. I wish you well. Not the sign the units for our angular speed. That's it. I wish you well.